fly to be allowed to pay him $500 to fly down there and learn about their.
Did you have to try out?
Yeah, he did. Yep. It's kind of weird.
It's very weird.
Yeah. But on the other hand, it was nice because essentially anybody that didn't look like a Hollywood executive or a rapper, you could just ask them what they worked on and they would start babbling about VR, projects. But it wasn't Hollywood. There were Hollywood moguls and rappers there. Other than that, I can't think of any other reason to have it in Hollywood because Hollywood's stinky. And $80 away from the airport. And who actually made it here that went? I saw Paul. Anybody else? Chris? No, Chris. Okay. So the conference, it was really short. It was just a couple of days, and I've got a random collection of photos that I can talk through. Where to start? So after the $80 cab ride, we decided to rent a car. So we got the new McLaren. No, that was just in front of the hotel. And other than that, Hollywood was just stinky and awful. Next. Can't do this with mouse.
Walking on the road there, stinky and awful.
It probably was, yeah. There's a sign in the distance. You can just make it out right there.
So we were actually in Hollywood?
Yeah, and there's some old buildings that are cool, but they're kind of stinky. There's the ILM gave a talk. You might have seen their promo video, ILM X Labs, that they kind of came out from undercover that they've been doing VR stuff. Technically for years, I would say, because they've done motion track cameras for previs and stuff for at least 10 years, using very expensive optical tracking and all those good Hollywood toys. But they've now kind of dipped into consumer VR a little bit with Oculus and the HTC Vive. I'll just go through these fast. So one of the most interesting things was they had to figure out a way to do real-time assets, sort of in conjunction with these ridiculous pre-rendered assets that render on a render farm for days at a time. And one of the things they did is came up with a common shading language. And I don't think, the scroll wheel does that, I guess. And they just kind of showed they have just a variety of essentially textures and different modifiers in the texture layers, and some real simple shading language to unify those, and then they can pop in lower or higher res geometry and textures. The stuff they did show, though, even in real time, looked pretty amazing. There's an example of a real-time asset in a speeder bike, and they just kind of painted up the rust patches to get the right appropriate amount of rust in real time to demonstrate that. Since they deal with non-technical people and not, directors and just random Hollywood executives and rappers, they kind of use an iPad for almost everything. So you'll start out visualizing or planning a shot on an iPad, and you can dial in pan, which is kind of intuitive touch controls like you use for most math apps that everybody's used to using. And these are low-res assets, low-res shaders at this point. And you can start to set, waypoints, and they've got all the camera terminology is done in terms of real cameras. So you can see f-stops and lens types. It's all Panavision lens standards. And then they can move into VR. So he's got the goggles on, but he's still navigating on the iPad, which would not work since you can't see it, other than the fact you've been doing that for the last 10 minutes. And if nobody says otherwise, you just keep doing what you were doing before. That's so great. And then they switched over to some really good looking stuff that's being rendered kind of off to the side in the cloud and being back to the iPad. So there's some latency there, but you end up with really, really nice looking stuff. And kind of their first outing of this is to just play this 3-minute clip and let you freely move the camera around, scrub time backwards and forwards. And essentially, there's some set piece of action, stormtroopers talking and, looking for droids, but you can pause them and veer off and go into the building next to them and see what's going on in there. So it's not that they plan on doing films this way. You can't have a branching world like that. It'd be too expensive. But they're thinking of little, set pieces and side projects as promotional things. So I get this muscle in them. You get a little bit of a sense of the shaders there. They just look phenomenal. And yeah, do you remember the ad that came to Tatooine? Remember that? Yeah. Looked really good. A little more of that. You can see the amount of textures going into everything. And obviously with the phone camera, it's not going to be the best. And there's an example of kind of scrubbing through it. And now he's adjusted the time slider, so everything's moving really slowly. And the other interesting thing is you can click on characters or objects and kind of snap the camera without having to have a fancy control scheme. So it looks like at this point he's clicked on a stormtrooper, the camera just follows 3 feet behind that guy's head to see whatever he sees throughout the rest of the clip. They added a Boba Fett because everybody likes Boba Fett. I'll go through this quick. There was a series of Oculus demos that they did a year ago to kind of show off really short set pieces of what's some of the cool things that VR can do and some of kind of the memes that are going to show up in a lot of VR projects. One of the big ones is checking yourself out in a mirror. Obviously, without tracking your face, you can't do expressions and stuff, so people always have to fall back to like a mask or some kind of abstract representation of the head. But it's still pretty compelling to see, the natural movements and everything. And miniature objects, they stylize this like a paper cutout town. It's another one that's showing up all over in demos. It's just really interesting to see essentially toys come to life. And having that God's eye view, you can move your head a small amount, but you can move like a block in their little toy town by just leaning over. It lets you see a lot of neat content. And again, with the natural head movement, instead of trying to use joysticks, you can fine tune that and like peek in a window or something, do a very delicate control. And then there was a whole series of things that totally failed that were really interesting and didn't actually get shown to anybody. They struggled with this one because of sense of scale. They wanted to have a planetarium kind of revolving around you, and they just couldn't quite get it to work out. There is a great demo called Titans of Space. If you have a DK1 or DK2, you should check that out. Not by Oculus, but by a guy named Crash. This is going to be a data visualization thing. And when they tested it on people, it turns out people don't like having their invisible body like sliced in half by planes of data. There's a good portion of people that you just cannot put virtual objects through them. It feels wrong. Once you've done it long enough, that you don't think twice about that, and it's a good measure of immersion in the games that are really drawing you in and you believe that you're in a world. You won't try to stick your face through the wall. You just won't. So the guys that are making those really nice games don't bother to black out the scene if you stick your face through the wall or anything like that, because people just don't do it. And you get the sense that things actually are solid, and it will probably hurt, and you kind of have to force yourself to do it. It's really interesting. Whereas in your just random thing that you made, in Unity yourself, you'll go through the wall and won't think twice about it. They did a electron microscope scale thing, and it was just too gross when that was up in your face. Nobody liked it, but they want to return to that. And then they tried to do a special effects laden piece with lots of smoke, particles, and you're going to be kind of in the launch tower just above the rocket and watch it take off. And they had 2 problems. Performance problems for all the particles and smoke and stuff, and they had people kind of situated above the rocket so you could watch it go by as it launched, and people just felt really uncomfortable and nervous and anxious about the whole deal because there's a heights thing going on, and then you get a rocket pointed at you. Yeah, it's just interesting to see. And they had a submarine thing too, and that essentially just got scrapped because they didn't have the time to complete it. So they had, I'm trying to remember when this was, about a year and a half ago, and they ran people through the first Crescent Bay headset, their 3rd headset they ever made, and they showed them, I think in 10 minutes, they showed them 5 or 6 different things. And at Oculus parties, you see things like that. People with headsets and weird cameras everywhere. And sometimes sometimes you see really, really, really expensive cameras. That's John's new camera. It doesn't have a price yet. Some of the best tweets talked about it was both sexy and frightening, and control your mind or kill you. I don't know much about that. They've kind of released the stats. There's 2 different ones. I don't know which one that was, but essentially it's just a whole nother step up and having more cameras and doing a better job of stitching the 360 image together. There was a number of them on the top. I think there was either 3 or 5 aimed up to try to capture some things above.
And did you get to see?
No.
See it working?
No, they weren't demoing it.
Who's that, John?
Jaunt, yeah. And also at keynotes, you get to see crazed Oculus fans wearing headsets running towards the stage. And then stopping short and whipping out weird gadgets and aiming them backstage, and I don't know what was happening. And of course, the whole thing was broadcast in VR by a couple of different places. Let's just see what I got in the slide. So the Oculus works closely with Samsung. The Gear VR is the Samsung phone holder that is probably the best mobile VR right now. And it requires one of the one that's coming out in November is the actual consumer release. There's been a couple developer releases, and it'll work with their kind of 4 newest flagship phones. And it's going to be only $99, so I think it'll actually sell quite well. And it is very compelling to actually try it out.
So an announcement came out while you were gone, while they did it, and a bunch of people came up on a bunch of social media, and I started looking at it. Holy cow! You know,
Yeah.
this thing's an Oculus, you know, competitor for $100, and then
You need a phone still.
third paragraph they say you need a phone. Oh, by the way, one of the most expensive phones that Samsung has.
Yeah.
So it is really just a phone holder. It's
Well,
which we're sort of going to talk about.
yeah, so we'll get to that a little bit later. The cardboard variants truly are not electronic. They are phone holders. This has got extra sensors and circuitry from Oculus in it, and it runs their software stack. And then actually, once you plug it in, it modifies the OS. It stops running Android, and the software gets actually front buffer access to the display. It goes into a low persistence mode that the phone never uses otherwise. So it is quite a bit different.
And they're going to be like selling them in phone stores.
Yep. Yeah, I'm sure there'll be mobile and stuff. Yeah. So the S6 is the cheapest these days. Starts about $400, and these go north of $800 for all the bells and whistles.
Zach,
That's iPhone pricing. What?
if they offer any kind of way for developers to have access to it before the actual release, do they talk about that at all?
Yeah. So there's been 2 what they call them? Innovator editions. And they actually gave everybody the conference the last of their stock of the second one. So the second one runs on the S6. The first one is over a year old. It runs on the Note 4. And you can find those on eBay and Craigslist and stuff. And maybe even still in stores, possibly. The funny thing is, though, they list for $200. And so if nobody knows about this announcement, they'll sell it to you for more than the new one. It hasn't changed all that much. Some little fiddly bits on the side. I'm trying to remember. Do you remember the actual detail changes? It's just slight refinements
Just
to.
the pad on the side changed a bit. There's no top head strap, which I thought was interesting.
Oh yeah,
The Innovator Edition has a strap that goes to the top of your head.
yeah. All the previous ones have a third strap over the top. And the weight, they claim it's 22% lighter.
Sort of or the right side.
Yeah.
Yep. Yeah, because the first one. It's very hard to find the touchpad while you're blindfolded with a phone.
And there's something else about the part that touches your face. It's been referred to people the actual ergonomics.
We heard a nice talk from Michael Abrash. Wait to see some of his fun illusions from previous time. This is just, I just snapped this picture because that was one of the craziest things he showed. There's a concept called binaural audio, and that's when sound is coming at you in real life, it comes from the front, it goes in your ear, bounces around a little bit and goes in, it comes from the back, it might pass through your ear. And based on living with your ears your whole life, when you hear sound attenuated in certain ways, you can pinpoint its direction very quickly. And binaural audio tries to reproduce that, does it with a generic sound filter for kind of a generic ear, but it's still very effective. With typical 3D sound, you can identify a direction. With binaural, you can typically tell if it's up or down, or in front or behind, without even using your your eyes. But this is how they capture that. They stick microphones in your ears, and they beam sounds at you from every direction, and it takes a half an hour. So that will be getting customized to your individual ears. Yeah, yep.
Oh my God.
Yeah, they literally do it like you think. They boink a sound from every direction, and then they rotate it, and then they do it again. I thought that was crazy. And then you talk in general, you know, VR, virtual reality needs to replace all our senses to be complete, and obviously we're mostly working on vision right now. And there's still a long way to go just on vision. It almost sounded like a recruitment pitch for PhDs and stuff. Just only looking at vision, he's estimating 5 to 10 more years of just pure research, not to mention making that economical. So it's only going to get better. Let's just skip over this. This is just a panel. Interesting video to check out. These will all be on YouTube in a week or two. This was Jason Rubin handpicked people that did things in VR that shouldn't work, and they work good. An example being, let's see if I can remember anything. One that's springing to mind was kind of constant accelerations and turning are one of the ways to make people sick. We'll cover that in more detail. But a guy kind of figured out a unique control scheme for a space shooter that generally everybody's okay with. So it's kind of interesting. Just different things like that. So it's you know, there's the do's and don'ts that I'm going to present, but you know, if you think something's really worth trying, definitely try it. Nobody's got enough experience to say what absolutely will not work. It's not like everything's been tested. The best talk for me was from Alchemy. They made Job Simulator, which we'll have a video of. And they just talked really frankly about hand-based tracking, doing games based on hand tracking and moving around a space. And I just snapped a couple pictures, real intuitive. So essentially all these trackers are either going to use visible light, infrared, or something like that. And so the big problem is occlusion when your arm blocks your other arm, you cross your arms or something like a bow and arrow, or your body blocks your hands. They just showed a couple slides real quick of why you will want more than one tracker, more than one camera. Even if there's two on the same wall, all these orange areas are seen by a single camera and they work fine. You just get this narrow cone right behind your body where your hands can't go essentially. And if, I didn't think the last picture was too blurry, but obviously if you put them on opposite sides of the room, that's kind of the best case scenario. That's the default setup for the Vive, but the Oculus Rift would be able to do that too.
Zach, I can't remember, didn't they say in the keynote that the touch sensors will come with its own camera?
Yep, second camera will come with the hand controllers, yeah. You don't ever know how big somebody's playing space is, so they went to the work of designing a couple different size levels for every one of their levels. It's kind of ridiculous, but the game is really focused on that one thing, and it really delivers more than any other game I tried there. I guess I don't have another picture of that. So just for example, in this play space, you can obviously see it's kind of blurry. It's a convenience store. That's the area you're supposed to move around in. If you had a smaller space, they would just pull on the counter and redistribute the cash register and everything else, so it's within easy reach. And they also talked about designing for height. They gave an example of one of the jobs is in short order cook in a kitchen, and little kids have trouble because they can't see over the top of the pot to make the soup. So you just got to keep things like that in mind. It's not really an easy solution for any of it. One of the big things is when you got virtual hands, there's nothing stopping you from pushing them through the wall or doing something that physically can't happen. As soon as that happens, your brain goes, oh, well, you know, that wall wasn't real, my hands aren't real. You lose kind of the magic of the whole thing. And even when you got to pick up an object, you know, objects are all different sizes. We don't have finger tracking yet, so it's a bunch of canned animations. So they contrasted what Sony does, which is for every object in the game, make up a hand pose and an animation to get to that pose, and spend all this money on art assets, versus what they do, which is shockingly effective. They just make your hand disappear. So when you reach out for that tomato, they tried to totally call it tomato presents. When I reach out for this mouse, the moment I grab it and it registers as a grab, my hand disappears and the mouse is there and I'm manipulating the mouse. I don't even notice. I played their game. I didn't even notice this was happening. Your hand disappears. There's a mouse there, and you're manipulating it because your intent is to manipulate a mouse. You don't care about the hand at that point. And if it just disappears, it can't do anything wrong. And it's a really, really brilliant solution. In particular, if you go for a something that's constrained in movement, like a drawer. You know, in VR, you grab the drawer, pull it straight out, that would be fine. But nothing stops you from grabbing the drawer and going like this. And then you get to decide, does it let go? Does it, what happens, you know? Does the hand just pass through it and the drawer moves on its own? Whereas if the hand disappears and you go like this, you can kind of make the drawer do what it should do and assume they're not screwing with you, they're actually trying to open the drawer. And they don't see the visual anomaly and it just works and they feel happy, like they accomplished something. That's one of the big things is when you get to these intuitive controls, people still don't want to actually learn skills. They don't want to be able to shoot a gun. They want to be cool and kill people easily. So no matter what you're making happen, you still need to put some training wheels on it and kind of infer the intent of the user and make that happen. So I think it's actually a really brilliant solution. Anybody that gets some hand controllers, I encourage you to try it out. Come back, please. There we go. No presence, yeah, I covered that. Oh, similar thing. So you're holding an object and you set it on a table. We rely on feedback. You know, you feel the table, or when you're picking something up, you push. You know, put your hand on the table, you feel it, and you close your hand. You don't get that in VR, of course. So it's real common to push things into the table or through the table a little bit, and physics engines hate that. That's something else to design around. What they chose to do is they're real lenient as you're pushing through the table, and then it's just gone way too far, and you automatically let go of the object, and it stays on top of the table. And again, while the hand's invisible, you don't see this gradually happening, that the tomato or whatever is passing through the top of your hand. It just kind of does what you thought it should do. We talked about drawers. Yeah, and cueing is not fun because it matters how tall you are, how old you are, if you're left-handed, all kinds of things. And they had a great story about after people have been testing for a while, they get done, they take out their controllers and they set them on top of a virtual table and let go. And then they fall down, the controllers fall down and break. And that happens all the time. So when you get the wrist straps, be sure to put them on and make everybody else do it too. In VR, in high-end VR, you're always going to be tethered. It's dual HD frames at 90 hertz, so you can't do anything like that over wireless. So there's always a cord coming out of the back of the headset. In practice, you get used to it, you're not tripping over it, but you don't want to encourage people to spin around. So all their workspaces have a wall in the back with nothing interesting. And they, by level design, try to encourage you to work in 270 degrees, not go continuously in circles. And so you'll see that with shooting games and everything else, that they really discourage you of turning backwards. And you should use proper scale. You actually can't tell the size of anything until you're actually looking at it in VR. John Carmack was showing off VR script. Has anybody read about that? Ever heard about that? In a nutshell, it's not so much about the language as getting a runtime on the Gear VR so that you can quickly test and deploy things, simple applications. And out of the deal, you get a state-of-the-art renderer built by John Carmack. And that seemed to be one of his other pet peeves is, you know, he publishes all the best practices and then nobody puts them in their projects. And the first use was for all these video projects that all they want to do is put up some photospheres and put a video on them, or maybe they have a slightly different physical camera layout, so they don't want the exact same sphere that everybody else has. Maybe they want a cylinder or some different shape. They have to go get Unity, they have to go get the Android SDK, install them both, figure out how to get them working, build a project, get all these settings right that nobody does because they don't read these best practices, push it out to the phone, test it, not quite right, change Unity, do it again. Where this just is hooked up and constantly running on the phone, and you're just sending these really lightweight programs across Wi-Fi, so that bringing in a scene and displaying it and getting walking around with some lights is just a small number of lines of code. This version connects to the internet and pulls assets off Amazon, AWS, but obviously with the closed garden approach in real retail phones, that won't be happening. The first version is going to let you do all this building on your network and then publish an APK that goes through the Oculus store through normal channels. But the debugging's very fast. There's close-ups of the new Gear VR and the phones. They had a lounge there where you could just sit around and drink coffee and spin around in chairs. And since Chris isn't here, we'll skip right to this. Chris's highlight, and maybe mine too, was so Chris is making a game for Gear VR, and it was in the lounge, but Palmer said he'd play it, and he showed up right at the end of the conference. He's all packed and ready to go, and sat there and played Chris's game for 45 minutes, finished the whole thing, got to the credits. And probably the highlight was when his assistant shows up and says his card's going to be here in 10 minutes, and he said, "Tell him to wait." And then he finished the game. So that's pretty fun. You can't tell it's Palmer other than the sandals, but it's him.
And he's wearing the same thing he wore the night before.
And there's one of Chuck's highlights, that it's a selfie with Palmer, and apparently this guy that caught the Minecraft sword during the keynote or something hit Palmer with it, I don't know. Maybe that's the last picture. Yep. Yeah. And then we had a couple videos to show. You want to go up here, Paul, too, and say a couple words while I'm queuing those up?
Sure.
So just kind of an informal recap. The keynotes are already online. All the talks will be online. I'll run you through kind of the announcements and show like 3 short videos, and then we'll call it.
Yeah, I actually put up a blog. If you go to Reddit or Oculus, you can take a look at it. But the most amazing thing to me was the sense of community. You'd go up to anybody, and like Zach said, that they want to talk about what they're doing, they want to hear about what you're doing, and that really came from the top down. Palmer spent about 2.5 hours talking to people at the party, just sitting there, looking at their stuff, waiting in line. John Carmack pulled up a spot in the hallway and talked for, I don't know, hours and hours and hours with people. So it was really unique in that you really got a sense that they cared about what you were doing. So I was really glad I went. I was a little worried that I'd feel like a small fish in a big pond. That didn't happen. So I would encourage anybody to go next year. Hopefully they'll open it up a little bit more, and that won't ruin the experience. But and the highlight for me, Zach works with. Oh, he's going to show it. It looks like. Okay. Touch. Zach works with haptic feedback all the time and controllers, but this was the first time I had a chance to work with touch in their toy box demo, and it was amazing.
Can you describe a little bit? This is super short.
Yeah. So what the toy box demo is basically 3 or 4 different worlds with toys on a bench. One has these toys, the robots, the blocks, the tanks. One has fireworks, which is really fun. There's a shooting gallery in one. And you come in and there's actually another person in VR with you, so that was another first. You can network with somebody. They later admitted that it was actually over land, so that kind of took the magic away, not over the internet, but still. And they run you through the touch controller, and I'd say in about a minute, I was really comfortable with that. It felt just like my hands, and I was picking up blocks and throwing it at them.
What was the touch controller?
Touch controller, well, do you see it?
You got a video here, back in. Close up.
Touch controller is a half moon with sensors on it, and it can sense your 2 fingers and what they're doing, so you can do a thumbs up or point, and it will take the other 4 fingers and turn them into a fist if you press down on a button. So to pick something up, you literally just close your hand and pick it up.
They were like demoing that at E3.
Yep.
Yeah, and now they had the Toy Box one, which was their E3 demo, but then they also had, I think, 4 others the second day.
Oh, no, there's like 8.
Or was it?
Yeah.
Yeah,
I didn't
see
list them.
One was called Bullet Train, and you could grab bullets out of midair and flip them back at people with your finger. But the thing to me was, it was just so much fun because it was so intuitive. So I was taking firecrackers and throwing them at the guy I was in there with. They had a little bit of physics, so things would blow up.
Did you touch each other?
We did shake hands and bump, but like I said, there's no
Nothing
resistance.
stops you. There's a little haptic buzz.
Right.
Okay, and we just sort of
Yep.
vibrate.
We played ping pong. That was fun.
I think that's in the video.
So, yeah, it changes. I've been doing VR for about 8 months to a year now, and had the Rift for a while. But this was an entirely different experience. It really changed what VR is to me. So, unfortunately, they did not announce the SDK. So this is still to be released to developers. But I think it probably by the end of the year, if I had to guess.
Hope so. We'll see. Did you do the shrink ray?
I didn't even know it existed until I
Oh.
got college.
I can describe that real quick. So the third room with the laser blasters, one of the things on the table is a shrink ray. And when you shoot somebody with it, they shrink down to, like 4 inches high. And then obviously from that perspective, there's this big guy looming over you. But the clever thing they did was they did a pitch shift on the real-time voice stuff. So they have a big lowered voice, big rumbly lowered voice. And from their perspective, then you switch it back and you shrink them. They have this little squeaky cartoon voice. It's really funny. And I guess, again, some people are uncomfortable with that because it's this big threatening thing all of a sudden. And this weird power dynamic. But one of the things that they did that I thought was real clever is you got this robot here that you can disassemble. When you're in small mode, you can rip off the hands and hand it, when you're the big guy, you can rip off the hands and hand it to the small guy and you can use them like boxing gloves. And then the other person you're with works at Oculus, so they're kind of leading you through the experience, making sure you see everything. He whips out the sock puppet and has it talk to me and boxing it with my robot hands. So that's pretty cool.
It really does change everything.
Yeah. Yeah, and like Paul was saying, I do work on networked motion control VR, and you don't go back once you've done that. But what they showed was running on the land. They were sending updates at 90 hertz of every pose in the system. They were sending uncompressed audio for the voice. Stuff I do with the internet, I'm happy when I get 10 hertz of updates 10 times a second. And that's due to all the drop packets and misordered packets and all the goofiness that happens on the internet. So it's still very compelling, but we got to demo this. What we're getting next year will be down here somewhere. It'll take a while to get up to that point, unless you're crazy enough to bring stuff and hook it up on a LAN, say up here sometime, and then do VR and interact with somebody that's already in the room with you. Doing VR.
So with that, tell everybody that if anybody knows anybody who has a Vive or interested in.
Yeah, has anybody got a Vive? Or see if no one in the surrounding states, town? Anybody?
Well, yeah.
Good try. Henry is their kind of animated short, but you can only watch it in VR. And like all things VR, you can't get across what's interesting about it on flat video. But so this has a lot of talking heads in it. No. That guy's saying stuff.
Old days of cinema, shaking was a key thing.
unplug and plug?
Yeah, I guess.
It's audio over HDMI.
Yeah, I tested this.
Switch your
I did, yeah.
The one thing they announced about Henry is if anybody's working with, what's the other platform besides Unity? Unreal?
Yeah.
I wanted to say Real, and I knew that wasn't right. If you're working with Unreal, that's what they did this in, and they're releasing all the assets to the, that they have for Henry, so you can go in and play around with their sets and stuff like that.
It switches back. So Colin, you got the insight into this, any chance?
It is outputting and it did work earlier. Gone? Oh, there it is.
Yeah.
So it's completely non-interactive.
Yep, yeah,
So he knows you're
so
there.
it definitely is outputting and it worked earlier.
Where there's that VR face that everybody asks me to do or not.
There was this here. On that switch box?
For the first time, you can actually be with that character.
Virtual reality is one of the few technologies where you can make characters that are so much more compelling than ever possible. In film, it's all frozen in time. In virtual reality, the actor is alive in every moment.
Just imagine if you're in a movie and a character will suddenly look at you. Henry will do that, and we will be aware that you're there watching the story unfold.
Henry is sure to be in the same room with some of the characters.
So it takes place in a single room, and they even put a rug down on the floor that matched the rug in the scene. Encourage you to, sit down or kneel or whatever, because Henry's a hedgehog that's like 3 feet high. But before you do that, you can lean over the railing, look down, and check out his bedroom. You can show that. And
I love working on it. And I want to.
it became a very real space very fast. They did great work on textures and anti-aliasing. And like they mentioned, he'll make eye contact with you and track your position during kind of key moments. And that was kind of the moment where it actually seemed like an actual living thing when the eye tracking was working. The rest of the time it was like a little stubby cartoon character, but still in a very 3D environment. So I think that's got a really interesting future. It's just, how soon will they invest the money? When will the audience be big enough to do that? To get it to go. So until I tried the touch controllers, that was actually my favorite thing at the show. If you have a DK2, there's a limited thing you can download. And like Paul said, if you have Unreal Engine 4, actually they have a custom version on GitHub that you can download. You can actually build the whole project yourself and see the whole high fidelity thing going. Let's just run through the rest of these real fast. Here's a real quick overview of everything from Connect.
Let's connect to Los Angeles, checking out all Oculus' new announcements today. We saw some new apps with Samsung Gear VR. We got some new touch experiences for Oculus Rift and the touch controller. And we got to check out a bunch of cool games. Let's hit the highlights. First up was the arcade for the Samsung Gear VR. Now, this is really cool. I got to check out a bunch of arcade machines playing classic games. I started with Sonic Hedgehog 2, but it gets a little distracting because you turn to your left, you turn to your right, and there's just another cool arcade game we want to check out. Next up was Twitch. This one took place in a virtual reality theater. You're sitting with a bunch of games in pretty comfy looking chairs and you're watching a Twitch stream. And there's the usual Twitch banter going on the side, but you're having a conversation of your own. Turn to your left, to your right, and there's a flower, maybe a blonde lady sitting on the chair next to you. Now, my favorite virtual reality experience has always been Job Simulator 2050. It's exactly what it sounds like. You're simulating something like a job. Now, there are lots of robots moving around, and they're all really rude to humans. Kind of displays what they're always doing around. But you sort of pretend like, you know, you're setting the facts, and you're making copies, or you're turning on your computer because you've got to plug in. And there's lots of weird hand motions you got to figure out. But it's a lot of fun. And the last game I checked out was Bullet Train. Now, this one is ridiculous. It's a first-person shooter, sort of. You have to grab guns that are lying around the environment, and you're shooting at enemies. The enemies are kind of guns, a little tank guns in a proper game. But the enemies are charging at you and you're shooting at them. But you can slow down time. You can teleport to different areas of the map when it dives away from enemies. But while you're slowing down time, you can toss bullets and missiles out of the air.
You see flicking the bullets at the end.
It doesn't make any sense, really, but that's why it's so much fun. And finally, this is probably my favorite out of the entire bunch. It's pretty much a clay sculpting simulator. In one hand, you've got a paintbrush. On the other hand, you've got a tool that modifies that brush. Maybe turn the brush into an actual spray can that's going to paint whatever you're trying to do. Maybe it's going to turn the brush into something that's going to extrude clay or shrink it or plate it or erase it or smooth out rough edges. You've got a lot of tools to work with, but they're all really simple to figure out. And then you're pretty much left to your own devices. So if anyone has piqued your interest, you can pick up the new Gear VR for $99 in November, and you can pick up the Oculus Rift early next year. I'm Nick Lau. Be sure to check out all of our
Thanks, Nate.
So gear-wise, the Oculus that you would play when you're playing the Oculus, same as the one last year?
Nope, so that's the final Oculus consumer release. That's fine. It's got better optics, they're more adjustable. It's got some really interesting design things. There's actual black fabric on it to help ventilate air through. I think it's the first kind of consumer product to have like this rigid fabric plastic treatment thing going on. And if you used an Oculus before, they're a little cumbersome to get on and off, but they kind of spring-loaded the straps. So once you've adjusted it to your head size once, you can actually just pull it away, there's some give, and just naturally take it out. It's sort of like a baseball cap kind of thing. And then it just looks a whole lot better than the DK2. Use that. Real quick, Job Simulator, my favorite experience. There's just so much interaction going on. This is kind of the expert playthrough with Claire. So there's things you're supposed to be doing, and then there's everything else you can do. It's just so much fun. It's got the shallow premise that human jobs don't exist, so computers do everything, and this is a recreation built for humans to play. So the phones have a 0 and a 1, your keyboard has a 0 and a 1. There's all these things that the robots got wrong. There's all these crazy gimmicks in there. I picked up the Magic 8 ball and said I should shake it, so I have to turn it over, shake it, and then turn back and says you're fired. There's just all these jokes just everywhere. And actually the guy that made this is kind of known because he's a juggler. And the controls for the Vive are sensitive enough. And I would assume the Rift 2, they just announced last week that they're using the Rift controllers. He can juggle in VR, and it actually works. There's videos online of that. We won't get into that right now, but a little bit over on time.
Ty's working on this.
Yep, so Ty left us to go to Texas to work on that. Here's a little bit longer video of Bullet Train. Just go with sound. You can imagine the sound. It goes like boo 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 rah boo boo.
Just slap.
Yeah. This is just like sensory overload. It's just crazy, and then you realize you can't get hurt at all, and then you slow down. One thing they don't show well in this video, you can see the bullets kind of slow-moing up there in the corner, but they just come at you like this fast, and you casually reach out and flick it at a guy, and then he dies. And so you'd be flicking them behind yourself and just doing all these silly tricks, just adding flare, flipping guns around. The one thing that didn't work is the two-handed gun. Again, because there's no feedback, physical feedback between your hands, your hand would just kind of slide through it or would do things you don't expect it to do, because in real life, when you push with one hand, your other arm would move back as well. But it's a great proof that FPSs will do fine in VR. It was super exciting and super intense. The one thing that's kind of weird too is the teleporting. They'd give you a key point to teleport to, so you don't teleport yourself into a corner. And then they orient you when you got there to be facing the action. So that was a little bit weird. So I'd teleport over to the elevator, but I'd be facing this way. So once you got there, you kind of look around to figure out what you were looking at. Anything else? Oh, Minecraft. I got Minecraft for VR. And for the Gear VR. For my toy box. Yeah, that's everything. All right, so let's switch over to the real talk.
What about hardware specs and PC hardware that you have there?
Oh yeah, so one of the other announcements, they announced the minimum spec for Oculus is the GeForce 970. There's going to be, Dell and Alienware and Asus and all these places are going to make Oculus-ready PCs, and they're going to start under $1,000. So that takes the challenge out of building a PC for people that don't do that kind of thing. So you're getting it? Yeah. It takes, we'll cover that, it takes a ridiculous amount of horsepower to drive these things compared to control games.
Did they mention any specialty in future generations of cars that are specifically for the VR generation?
No, yeah, that's a good point too. So the VR horsepower requirement, the video card manufacturers are on board with selling more expensive cards. So NVIDIA and ATI have already made specialized drivers for VR. They just got released, at least the NVIDIA one did, I don't know much about ATI. And they're just getting rolled into software now. And so those allow this really tight timing that you need for low latency tracking and so on. And they're going to allow asynchronous time work on PC. And what that is when your head's moving around, you always want the frames to be updating and following your head. And if this game misbehaves and takes too long to spit out a frame, there's a trick that all of the headset manufacturers are using now to just kind of warp the last image to roughly approximate where your head is moved to. And it works well. It keeps you from getting sick. There's certain things that'll distort if they're very, very close to you, but if things are 5-6 feet away like this post, it's convincing for up to a full second. You really need it for like 1 or 2 frames to kind of fill the gap when an app is slowed down. So expect a lot out of that, and no specialized cards announced, but I bet you there will be one Q1 2016, some new Uber card that is better than everything else. So Paul and I are splitting up this talk. I'm going to give a general VR stuff. We already touched on a little bit of it, and then Paul's going to go specific on cardboard. Any point, shout out questions. Can you guys hear me in the back, or should I get back on the mic? It's good? Okay, just tell me if you can, if I start mumbling. Shout out questions at any point. Shout out how this won't work, this 3D TV didn't work, whatever you want.
I think flat TV is a gimmick.
I know where your allegiances lie. There's kind of different tiers of VR. We're mainly focusing on the entry level, getting started stuff, and that's Google Cardboard. And there's kind of these different layers of capabilities and technology as you move up in the different tiers. And I'll get to these in detail. They're all summarized in one spot. And with that, you get different capabilities, things you can do, comfort factors, and different experiences that you can create. So starting with Cardboard, I refer to it as snack size VR. The main reason is you actually, unless you're one of these people that's totally immune to simulation sickness, motion sickness, You literally cannot do it for more than 5 or 10 minutes. But that's fine. It's like a $5 thing. It's made out of cardboard. You can assemble it and color on it. It's a really clever idea. And there's a wide variety of them. In fact, they're re-releasing a Viewmaster branded one this Christmas. It'll be a lot of fun. And there's even ones that aren't cardboard. This is the one I use, mostly because it just folds up very compactly. And there's a lot of variation in how they trigger the screen, how they do a tap. The original cardboard used magnets, kind of a clever hack, right? You throw a magnet in there and it disturbs the compass in your phone. And it registers as a click. If your phone has the compass on the right end of the phone to be next to the magnet. And then the other downside was it's using the accelerometers to detect rotation, but those always drift over time. And most hardware uses the compass to correct for drift, but that's now got a magnet next to it, so it's out of action. They've since moved on to just playing on tapping the screen if you can reach it, or they've made little levers in there that are right between your eyes, and you just push down on the side, there's a contraption that goes out and taps the screen inside the box.
Are there any of those that fit a bigger phone?
Yeah, so that's one of the things when you're buying it. Certain phones will fit in there and certain ones won't. The one I brought is plastic actually. It doesn't have sides, it's just got clips. And that means you can cram a giant phone in there, you just won't necessarily be using all of the screen. So this, it looks like it goes the other direction, but it goes like this, and you put your phone here, and it focuses right at this distance. This will hold anything that's an iPhone 5 or bigger, and cardboard does run on iPhones. And you put large phones in there, they just stick out a little bit. The one that actually looks the best in here is the iPhone 6 Plus, the big one. Looks really good in here. The other nice thing about this particular guy, I plug it a lot because I just love it. It's portable, you can put it in your shirt pocket, hang it on your shirt. You can slightly adjust the lenses in and out if your eye separation doesn't quite match the lenses. And most of these other ones, they're typically fixed. Again, that's a fine-tuning thing, and if you're doing VR in a cardboard box, you shouldn't really expect all that much.
What was your comment you said right away about getting sick and doing it for 5 minutes at a time?
Sure, so we'll kind of cover that in a little bit, but these don't have an optimized screen, optimized tracker. They're really just the bare minimum of it can track my rotation, and it's got magnifying lenses to give me a wide angle view. I'll show you a little bit here about the next step. Oh, another thing, because the motion can get to you fairly quickly, they actually don't strap to your head typically. They encourage you to hold them with your hands. And that's kind of a clever hack because now I'm turning with my waist. And I can't turn very fast. If I took my hands away, I can turn my head really fast. And that's just a clever thing to slow you down a little bit and keep you from making yourself sick. With any VR experience, if it's not insane, you get a freebie for like 5 minutes for most people before you notice any problems at all. Moving up is the Gear VR. It's again a phone in a specialized folder. So again, we've got the rotation tracking still. And now we've added a low persistence display and low latency tracking. A low latency tracking simply means that the moment you turn your head until the time that actually affects pixels on the screen, they call it the motion to photon latency, is low, under 20 milliseconds. That's not typical with cardboard and other things, or computer monitors for that matter. So one of the big differences, Android is typically triple buffered. By the time you draw something and commit it, it goes through 2 more screen flips before it actually shows up on the display. In Gear VR special mode, the software used to write directly to the frame buffer and decide it could right in the middle of a scan out and tear a frame if it wanted to. It's kind of bypassing the OS in that way. And low persistence display, I'll cover it in more detail later, but for now we'll just say that it's essentially displaying the image and then blacking it out and then displaying it again. So similar to old CRT monitors, screen's actually dark most of the time. Humans have persistence of vision, and then we fuse the images together anyway. I'll cover the advantage for that later. I don't got a name for these. Just the next step up is 6 degree of freedom track headsets. So now we're not just tracking rotation, we're tracking your head position in space. This is really important for being able to get closer to things and lots of movements like that, but it turns out it's kind of important for not even trying to move around. Your head naturally wiggles, and what should be happening is these pillars should be parallaxing a little bit as they do it, but if I don't have position tracking, they just kind of are cemented to my head. Unless I rotate, and then they aren't, it'll mess with you after a while. And a higher refresh rate. So the Sony, the monitor actually refreshes at 120 hertz. The other one I put up on the condensed slide was the Oculus DK2. It is a 75 hertz refresh. And that was the first headset that didn't make me sick. And I've used these things constantly. Then for lack of a better name, just the PC VR that's coming out next year, into this year. The Vive, manufactured by HTC, Valve, basically did all the R&D for it. And the Oculus Rift, the real one, the consumer one, looks like that. It's just a lot smoother and sleeker looking, and it's got the integrated audio, microphone, and adjustments. What we're adding now is essentially just quality in all metrics. Higher res, you get to use the strong GPU and CPU on your computer, and adjustable IPD, interpupil distance. So the screens really should line up in front of your eyes, and if they don't, you don't get the best possible picture, and things don't look like they're the right size. And then we've talked about stuff that's coming in the future, hand tracking, standing around and walking. And with that, like I mentioned, the Vive can track things in up to a 15-foot square. These guys actually have a slightly bigger space. And there are these little tiny laser emitters that go in the corner of your room, and they just spin. They've got the equivalent of hard drive motors in there, and a reflector and a diffractor, and they just sweep lasers around the room. And then it's up to the headset to have that sweep go by and do the timing and the math. They call it lighthouse because it's similar to how you triangulate, like if you were navigating on the ocean. And you can determine a pose relative to those two emitters based on just the timing as the light sweeps across your infrared detectors. Oculus has it the other direction. These are LEDs, and there's cameras looking at you, and it looks for the light coming out. And there we have the touch controller. It's got some capacitive buttons on that we didn't talk about in detail, but what's unique there is it can actually let your fingers show up as movements. So if you move your thumb along the side, it shows your thumb moving. If you flick your finger, that's a mechanic in a lot of games to actually flick things or attack things that way. And obviously the grabbing and so on is on there. And they're very ergonomic. They actually can't drop them. They put a wrist strap on you anyway, but you'd almost have to kind of go like that to get them to fall out of your hand because they just kind of lay there so nicely. And they have that loop, which is essentially more tracking surface area. So it's harder for you to cover them up and include them. Just a quick video here, just some perception stuff. VR doesn't look like reality. You can see that in all the videos. It doesn't look like real life. It's just giving all the cues that we need to perceive it as a 3D space that we're inside of. These are just, I think, like 4 minutes, a couple of fun illusions here. Yeah, that's Mountain Dew. Any questions? I'm going to keep going fast unless you guys ask questions. I know it's real over on time. Does anybody know why when I embed a video in a Google slide, it doesn't respect the time in the URL?
It's on Facebook either.
Okay. But if you put it as a link, then it works fine.
Nerve impulses sent by your sensors, based on its model of the world.
This is class participation.
Of what makes VR different and more powerful than anything that has come before.
Pick a pill and keep your eyes on it. Got it? Let's mask off everything else.
Whoa.
Interesting. You were pretty sure that out there in the real world, one pill was red and one was blue. But they're exactly the same shade of gray. Take a good look at the blue tiles on top of the left cube. Okay, now take a good look at the yellow tiles on top of the right cube. You think those are colors you're seeing now? Let's mask off everything with those particular tiles. They're all exactly the same shade of gray. See the white tile under the desk?
You never
Black
guess what
tile
happens.
jumped outside the desk? Again, let's mask off everything else. And again, they're both exactly the same shade of gray. But if one of them is in shadow and is that shade of gray, it must be white. And if another one is a bright light and is that shade of gray, it must be black. Your visual system does the inference for you automatically, and what you see is white and black rather than gray. Here we have a nice square checkerboard. Let's add some dots and see what happens. This happens because some line detector is fired that normally wouldn't be triggered by a checkerboard. Rather than looking orthogonal, the corners look bowed. Take a moment and figure out which of the two tabletops in blue is wider as measured in 2D and which is longer, assuming you rotated them to line up. Ready? They're exactly the same size. Fixate on the yellow dot and observe which way the black and white dots are rotating around. Next, look at the blue dot, and while continuing to look at the blue dot, see out of the corner of your eye which way the black and white dots are going around the yellow dot now. Move your eyes back and forth, and you'll see the rotational directions change, even though they're not actually changing. If that doesn't work for you, look at either dot, then move your eyes up until you see the direction change. Of course, the straw isn't really going through the window. What's happening here is that you're making a very reasonable assumption about the world. That happens to be wrong. There are a number of cues on the window that imply a perspective that doesn't exist. So your visual system infers that the window is spinning backward for half of a full rotation. As a result, the straw seems to rotate right through the window. This doesn't match any reasonable model of reality, so you end up seeing something impossible.
Has anybody had one of these at home?
Okay, that's just weird. Here's what's actually happening. Real objects, especially faces, tend to be convex. So your visual system assumes convexity in the absence of cues to the contrary. The only way to make that assumption work in this case is for the head to be moving in very odd ways. So that's exactly what you see. As the oracle might say, here's what's really going to make your noodle later on. Now that you know what's happening, try to see the dragon as it really is. I bet you can't do it. A little bit of conscious knowledge isn't going to undo millions of years of evolution and a lifetime of looking at faces.
Bar, 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 bar.
Obviously, she's saying bar, bar, bar. Now let's watch a slightly different video.
Bar, 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 bar.
Here we clearly hear her saying far, far, far. Except that she isn't. The video shows her saying far, but the audio track is still of her saying bar exactly as she did in the first video. The visual input overrode the audio. To make it crystal clear what's going on, let's look at this one more time. Once again, we'll have a soundtrack that says bar, but this time we'll have a split screen with a face saying far on one side and a face saying bar on the other. As this plays, move your eyes from one side to the other and observe how what you hear changes.
Bar, 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 bar.
That work for everybody?
Oh, yeah.
Yeah, it's interesting. I've liked optical illusions for a long time, but I've never seen one Has anybody printed out and assembled that Paper Dragon? It's been on the couple back there. Yeah, that's been on the internet since like the late 90s. It works really, really well. The only trick is don't let it self-shadow. You don't want a shadow inside the concave head to give away the fact that it's concave. So you just can't eliminate it from the top. But yeah, it's out there, it's free. The point being with this is these particular illusions don't play that much in VR. The ones that do, we can't show you on the screen, but you don't literally interpret and perceive what you're actually seeing. There's all these layers of pattern detection, mental modeling, and all these things going on that influence and filter and condense down what actually makes it to your brain. And that's the only parts that you need to get right. You don't have to match perfectly shaded, real world surfaces. Do this really fast, because it's still pretty awesome too. All right, who wants to pronounce it? Good, yeah, everybody, vestibular ocular reflex. You sound really smart when you say that at parties and stuff. And plus you can do this demo to strangers.
The third motor control, ocular motor control system is going to be that of the ocular motor reflex. I want you to look at that point right at the very distant part of the wall. Keep focus right there and don't move your eyes. Keep focus. I'm going to turn your head quickly, but you keep looking over there.
Do this at parties.
Go up and down. Okay.
So this is truly a reflex. It demonstrating there, it doesn't have to be your intent or your own muscles moving your head. We have the equivalent of accelerometers and gyroscopes in our inner ear. And if you're focused on an object, if you're looking at a point in space, and you can turn your head absolutely as fast as you want, hurt your neck, you will stay locked onto that point in space. It will stay imaged on the exact same spots in your retina, and it will never blur. You'll never get motion blur. That turns out to be a huge, huge problem in VR. I won't play this whole video, I'll just do a couple seconds just to show you why it's such a big deal. So this is one of the things that's lacking when you don't have a low persistence display, when you have a routine full persistence display.
Suppose you're looking at a normal monitor in real life, and there's a dot in the middle of that monitor, a red dot. And you're looking straight at it, and then as you're looking at it, you turn to the right, while continuing to look at that dot. As you turn your head to the right, you don't even notice it, but your eyes reflexively turn to the left at the same time. That's referred to as the vestibulo-ocular reflex, and it's extremely precise at tracking objects as you move your head and ensuring that they continue to project onto the same spot on your retina. The result of that is you don't perceive any motion of the object across your retina, and it remains in focus and sharp. Now say you were wearing a head-mount display, and in the virtual world, the monitor exactly the same size and distance from you as your actual real monitor, and there was a dot, a red dot in the middle of it, just like the one in your real monitor we mentioned a minute ago. Now, if you want to turn your head to the right and continue to observe that dot projecting onto the same point on your retina and being just as sharp and in focus as it would be in real life, then the red rays that show where it crosses the head-mounted display screen, those represent the pixels on the display. They have to shift to the left in real time. And they have to update at the same rate that your eyes are updating their rotation as you turn your head, which is on the order of 1,000 hertz, far, far above any refresh rate of any monitor that exists today. So what does it look like when you're using a real monitor that has a more typical refresh rate on the order of 60 hertz? Well, this is what it might look like.
These are the
if you
pixels
slowed it
moving
down
one by one
many times.
to the left on that display.
As you can see, each time the screen gets a new image, the screen updates the location of the two red pixels on the head-mounted display of the screen. Between updates, as you continue to turn your head and your eyes continue to rotate, the image starts to move across your retina because your eyes are still rotating, but the image on the screen is not changing. And the result is that you perceive the pixel to be moving, the pixel on the virtual monitor to be moving to the right, and then returning when you get the new image to its correct position, and then moving to the right again. And it does that over and over, and it does it so quickly that all you perceive is a blurred horizontal line. So how does Crystal Code fix this? The answer, in short, is that on the Crystal Code prototype, the screen is black most of the time. The only time when the screen displays an image is when it has just received an image, and that image is in exactly the right place, and your head and eyes are in exactly the right place, that image will project it onto the correct place on your retina. It displays each image for less than a millisecond, and then it goes black. If you do this quickly enough, your brain will not notice that the screen is black between the display of the brief images. The result is that those flashes go to the right place on your retina over and over and over again, and those images all kind of blur together to form a coherent.
It's even better than that. When it's blacked out in between images, your brain interpolates what happened in between in smooth motion. So that's the need for a low persistence display. In practice, what you see if you have a routine, a normal display, is just kind of a smearing when you turn your head. If you were to actually not fixate on an object in the virtual scene, it's really hard to do, but say if you had a crosshair that was stationary on your display and you fixated on that instead, it wouldn't look as blurry. It's only when your eye does its tracking thing on a pillar or a tree or a tiger that you see that blurring happen. Let me just burn through the rest of these people's halls. One last video, I'll just show 30 seconds. So I can figure out how to maximize this again. Is it like F11 or something? Moves up. The big bugbear in VR is simulator sickness. We've talked a lot about visuals. You've got all kinds of other senses. The big one for VR is your vestibular system, these accelerometers and gyros in your ear. Since you've been very little, you've been using both your vision and your vestibular system. It's another great word for parties, to help you balance and keep you from falling over. And they're meant to be in sync. They're locked together. They expect to agree. They can, to a certain extent, one can accommodate for the other. Obviously, you can still walk in the dark without falling. They are meant to be together, and when they aren't, you feel weird. So the need for a low latency head tracker comes in, and the low motion to photon latency is, if you can imagine that the world is tracking very well, but it's just delayed on your display here. It's just you turn your head and then it comes with, and you turn your head and then it comes with. It's always a little bit behind. That's a drunk simulator, and you will get sick. And typically, older VR headsets have suffered from that. The Oculus Rift was one of the first cheap headsets to have fast tracking. It updates at 1,000 hertz, 1,000 times a second. Even with really great, wonderful, wonderful hardware, you still got to avoid moving people around too much, because just because the visuals match, there still can be a big disagreement between your eyes and your ears. So if you got me on a roller coaster or a swing and I'm accelerating and turning, and my ears say, no, you're just standing there, that will bother you. It's like car sickness. It's a disagreement between what you see and what you feel. And there's this theory that's pretty well accepted that it's an evolutionary thing, that this is happening, you probably ate some weird, crazy mushroom, and you should throw up now. So that's why the sickness kicks in. And we see people staggering around at parties because they drank too much. You can tell about their vestibular system. And there's just one really, really great experiment I just want to show. I'll skip the other video.
When we move the room backwards, child falls. And again. In 92 trials of this type, 7 infants, balance was clearly disturbed in the predicted direction in 82% of the trials.
So toddlers haven't locked their vestibular system to their vision system.
That for the infant learning to maintain balance, visual information is far more potent than the
This guy gets paid to do this. Yeah. Pick on toddlers. Got on right at the end there.
Mechanical information. And movements of the room do not, as with the infant, knock him over. But let us give him an unfamiliar balancing task, such as standing on a narrow beam. With his eyes closed, he depends solely on mechanical stimuli, quickly becomes unstable and falls off. Or, with his eyes open, if the room is moved, even slightly, he will lose his balance, just as the infant did.
So that is the most literal equivalent experiment of a VR test that you can have. The world's moving and you're not. So that was great that they actually did that research back in the 70s.
If you did that space simulation at the Science Museum, it's the same thing.
Yeah, that sense.
There's a wall, they have the whole room rotating around you.
Space station.
Yeah. the space
Oh, okay.
station, yeah.
Did it bother you?
Yeah, a little
Some
bit.
people did.
Yeah.
They told me, close your eyes.
Yeah, you gotta-
Yeah, exactly. There's no physical sensation, so just close your eyes.
And they had a railing for you to hang on to if you were, even though you weren't moving, just the walls were turning around.
It's like that stuff at Luxo, the turnbuckle in Tumbo made all those years ago. You know, if it starts bugging, you just close your eyes.
Yep.
It goes away.
Yep, and actually that's a great trick for VR. If you find some aspect, you really want to keep playing this demo or game, and every time you turn you feel sick, people have figured out just to survive, just close your eyes for a little bit and then turn and then open them again. If it's something that you're in control of. So I'll just run through these really fast. These are common pitfalls when you're starting out. They're all over the internet. They're in the Oculus Best Practices Guide. If you want to read something long, full of amazingly good information, go there first. 3 to 5 minutes is where the stuff starts to kick in. There's some ridiculously extreme, theme park simulators that can do it faster. But in general, if you've got a very short experience, you don't have to worry about this as much. If you have anything longer, you definitely have to worry about it and you have to design around it. Maintain your frame rate, maintain your head tracking. Obviously, if you're not doing that, instead of things moving or counter rotating, so that if you're fixed, they'll just be plastered to your face for a little while. You'll see kind of a judder, stair-steppy thing. You might see a double image. Don't ever take control of the camera or the viewer. This is tough for the film people. You really just let them be and then do things around them. It feels really bad. Minimize rotations and accelerations. Some of the workarounds are like the teleporting thing we saw. It can be on a constant speed. When you're going 600 miles an hour on the plane, you don't feel accelerations. It's a constant speed. Some of the other workarounds people have used is like flight simulators, cockpits, block your peripheral vision. And you can do a lot more weird maneuvers in there because you have a stable frame of reference. And when people are sensing motion from their vision, it's all peripheral. It's the sides and especially the ground. If there's movement below you, you assume you're moving. Your brain does. Jump scares are super easy and super lame in VR. Get off my lawn. All you have to do is put something behind the person and then make a noise. Then when they turn, they flip up. If you actually make it scary, it's that much worse. Don't assume where the viewer is looking. You can never assume. This is, again, tough for video. Use cues, sound cues, or something to guide them, visual cues, different kinds of swipes and types of things. And you can trigger content based on where they're looking, or actually move the content to where they're looking. And people have even done this in video. It's really clever. There was a movie last year, Reese Witherspoon backpacking. Anybody see it? The Wilderness. Yeah. They did a VR trailer. In one of the scenes, she's just in this clearing doing camping stuff, and you're looking around, checking out. You know, there's like a big boulder over here, and then she's doing something over there, and then next time you look back, a ghost or a remembrance of her mom appears there. It's not until you look, and they manage to loop the rest of the video so that you can not look over there as long as you want. It just keeps repeating boring stuff until you eventually look back, and then you get the reveal that they intended. You're not looking in the wrong direction. Because it's, again, not a big scary jump thing, it's this pleasant, you know, ghost remembrance of her mom. Use a variety of depth cues. Everybody likes to, you know, I got stereo vision, I'm gonna poke things in your face. But there's a ton more, and really you want to minimize up close things. It's a little uncomfortable after a while. Relative and familiar size. Everybody knows how big a can of Coke is, or a notebook, or a pencil, or a door. Doors are standard size. Put things in the scene. If you got giant alien monsters, put a house or a car next to them. Parallax, obviously, even with position tracking, it's super good. You can do it even very, very far away where it's only a few pixels, and it gives you a great sense of depth. And that works, of course, if you've only got one eye, you still get all those cues. If with head tracking and only rotation, you still get that. It's just not as pronounced. Depth fog, you can use to great effect, or just making colors less vibrant, less saturated as they go away. Texture gradients, so things up close should have a lot of detail, things farther away should not. Relative detail in geometry, breathables, you know Star Wars spaceships are big because they got all the tubes sticking out of the side, so it must be really big. And 3D audio, which is often neglected. And then test often on a variety of people. It's really surprising your great ideas only work for you because you knew what you were trying to do, and no one else gets it. And likewise, things that probably shouldn't work sometimes do work. And a huge one is use abstract and simplified design. And Toy Box was kind of a tour de force of this. Obviously, we've got no bodies, we've got no elbows. You can still picture where their elbows are, you know exactly where their elbows are. No mouths. They would do kind of a ripple distortion on the face to let you know that the sound is coming out of this face. And also you've got the 3D audio that points towards that face. But they didn't want to put lips on there and animate them wrongly because incorrect cues or incorrect evidence breaks you out of this illusion. If it's missing, you'll infer it. If it's wrong, it's kind of a showstopper. Very simplified objects. This is a GIF, so the shading's gone to crap. But you can see it's very abstract things, very simple lighting. And then pay close attention to things that don't seem quite right. So they worked on these hands for a long time. And they ended up with kind of a ghost shader, but it's not really transparent. You can't see things like through the back of this guy's hand. You can't see the handle of the paddle. Because they found that when they started with just a nice ghost thing, like it didn't feel like you could really pick things up. It didn't feel connected and solid. And they render the equivalent of a ghost shader, but then they Z-buffer it, so nothing can render transparently through it.
They're going to give those hands away with the SDK.
I don't think they're giving them away.
Well, not giving them away, but they'll be included.
Yep. Yeah, and then just a little bit about cardboard differences. Have you messed with this at all, Paul? The building the profile?
No.
I'll just show it then. I haven't either. I haven't actually bothered to fill it out. But there's these QR codes on the side of the viewers that you scan them in the Cardboard 2 apps, and that configures the library to know, theoretically, the size of your lenses, the field of view, the distance, and some of that geometry stuff. So you come on this website, you fill out all the stuff about the hardware you're about to sell, lens distance, inner lens distance. It's all very nicely done. The distortion of the lenses. And that makes the render a little more accurate than when you plug it in there.
This is if you're selling a viewer.
Exactly, you're building one or selling one.
This is to get your QR code.
Yep. And then that'll get encoded. Oh, hey, you made the slide. You want to talk about?
Oh, yeah. All right. We'll jump on here. So, hi, everybody. It's almost time to go get drunk. My name is Paul Christian. I've been coming to this meetup for over a year now. It's excellent. And one of the great things about it is you get hooked up with great business owners who are looking to, get in the VR scene. And so Britt over here, I met a few months ago, commissioned me to build a Google Cardboard app for his real estate tour company. And they have an extensive library of existing tours. Brad here does a lot of the photography for it. And they have their kind of proprietary but open camera setup to go around the houses and make a whole 360 photo tour that you can walk through. Well, if you're familiar with Mist, it's very much like that, game from the 90s, where you're here and then you zoom over to here and you look around. But anyway, this is my first experience doing Cardboard app, and also just getting into learning Unity. I chose Unity for some of these reasons. So the Cardboard SDK, they give you two options. You can use the Android SDK, which involves basically Java. You're writing Java and OpenGL. So if you're already familiar with writing games with code, and OpenGL, and that's familiar and great, that's definitely a good option. And I'm familiar with this through use of processing, which is kind of a higher level wrapper to OpenGL. So I think that's also an option. You could, kind of shoehorn in something like processing to do the rendering for you. But it's limited to Android as far as I can tell, and we definitely want to expand to iOS because I'm sure a bunch of you have iPhones. So that's where Unity comes in. Unity, you can potentially build, write once and deploy to many different platforms. Android and iOS are supported in the Cardboard SDK. It comes with a pretty decent, 3D game engine and editor, so you can kind of look and edit your scene in real time. Not while the game is running, but at least you can kind of poke around in the 3D space rather than trying to imagine it in between build and deploy cycles. One of the downsides is the whole architecture of the app that it spits out is sort of opaque. You don't have a lot of visibility into what it looks like, and so it's sort of challenging to do things that would have been pretty, easy if you're already an Android developer, such as launching the app from a URL, say, or from another app, with a share link. And when you launch the app, you want to get that context of the link to place the user in, this house versus another house. I'm finding it hard to actually get that information. It's unclear to me whether the Unity app is in the same Android activity as the thing that it was launched from, if that makes any anyway, I guess I could give you a quick tour of the demo cardboard app that you can download and just get started right away, basically. I was going to go through the whole process of creating a fresh new project and loading up the cardboard demo in there, importing it. But if you can read instructions, then I think you could probably handle that. How many people here have actually used Unity before? And okay, you're probably all more familiar than I am.
For everybody else, it's important to point out it's totally free now.
It is totally free, and that was another big selling point for me.
What do you mean by totally? Well, the SDK.
All the features of Unity are free now. Totally.
I thought that the profiler and stuff is still appropriate here.
Not in 5.
Really?
Yeah. So you gotta show their splash screen, that's about it. And there's some weird advertising network you don't want.
Right, but you still have to do that.
Hmm?
You still have to do that.
I don't have to do that.
No,
You might have to do that.
The splash screens.
Yeah.
Yeah, if you're like selling an app and you don't want their splash screen.
Alright.
So it's. Okay.
So all the things you want to do are totally free, but there's a splash screen and you can have the ad network.
Yep, there's a splash screen. So here's what you get with the demo cardboard app. It's installing some stuff. Okay. Actually, let me just close out of it. Start it up again.
I'm going to put down the mic and just talk loudly. Yep. Over here on the left, this is everything that's in the scene. So there's a cube, there's a plane. Cardboard main is the big thing that you get with the cardboard SDK, and this is all the stuff that you really don't want to think about when you're just getting started. And this gives you a model of the player's head and face, and attached to that are 2 cameras, left and right, and it takes care of the lens distortion correction and rendering side by side, as you need for a VR viewer. And it takes care of head tracking for you. And you just deal with placing stuff in the scene and moving the head around, and moving the scene around. press play, this is an emulated device, and if you hold Alt down and mouse around, you can look around the scene. This is presumably what you would see in the cardboard.
So mousing down, simulating head track.
Yep. And you only have rotational tracking unless you go down the road of some third-party stuff where you can set up QR codes around the room and do a little bit of positional tracking that way. But most people probably won't do that. You're probably going to be, on a bus killing time. So you just want to look around. They give you this cube with some stuff that's shooting out of it, and then when I look at it, you can see a little kind of laser pointer that says, okay, this is an object that's colliding with my raycaster. A raycaster is a ray 3D space that's projected from a pixel on the screen out into your game environment, and you can do collision detection with your game objects to see what 3D things you're looking at. So when you click on this, what happens? It just teleports the cube somewhere. Let's look at this cube. Over here on the right side, you have the inspector, and this object is called cube. You have a transform, which is your position and orientation in space of this object. You have a mesh filter, like what mesh are you going to render? You could change this to sphere if you want. And there you go.